Hey Selena, how are you?
Hi, Simon. How are you?
Yeah, I'm good, thank you. Good to see you again.
Good to see you as well.
Hi everyone, and welcome to the third Hydrographic Society and Norwegian Offshore Surveying Positioning Forum joint event. We've got a couple of speakers this evening, and I'll let Selena introduce them to you. In the meantime, whilst I've got everybody's attention, I would just like to let you know what Hydrographic Society events are upcoming. We've got the golf event on the 12th of September at Kemney, and I'd just like to thank Alan McDonald for organising that for us, and I'd like to thank our sponsors who are UTech, Intermore, Sonodyne and Norbit this year. Thanks very much for that. And ongoing, we have our Emerging Talent Awards, which run through 2020 and will be announced in 21. So that's it for us this year, Selena. So over to you.
That's great, Simon. So you guys are running ahead with a golf tournament despite the corona situation, or is this a virtual golf tournament?
Well, we are currently going ahead with it. However, we're going to adapt and change as we have been throughout. But people in Aberdeen are currently locked down. Pubs, bars, and restaurants are all closed at the moment, and travel is restricted. So we have a meeting next week, which we will discuss our upcoming golf event based around the lockdown, which is happening in Aberdeen at the moment, which is just being extended for another week, I hear today. So we'll just have to be adaptive as we are being now.
That's right. We're doing the best we can in otherwise relatively challenging situations, aren't we? All right. Well, on behalf of NOSP, I'd like to welcome everybody as well, and throwing up the sponsors on the screen as always, because we are very appreciative of all of the help that we can get. The board works as best we can despite these corona situations and being stuck in home offices all around Norway. But if we didn't have the financial support of these sponsors, it wouldn't be possible to do anything at all. So we very much appreciate, despite these challenging times, that we continue to receive your support. Today's event, I can see we've got 38 people watching the live stream right now and 19 in the Discord room. If you're not in Discord, you should be, because that's where you can chat both with old and new colleagues, both in the Scottish side of things and on the Norwegian side of things. So welcome into the Discord room. If you need the link, it's on nosp.no. You'll find the link there on our website. Wanted to also share what's ahead for the NOSP side of things. We have planned an event in September on the 10th. It'll be an online event such as this. And my best guess for October is it will also be online. Use the Discord room. Absolutely, if you have any comments to us about what we should do in November 19th, we have booked already a restaurant and the oil museum in the petroleum museum, in Stavanger. We would love to hold that event in person, but we're really not sure what situation is going to be, whether people would come even if we're allowed to hold it, and so on. So if you've got any thoughts, please let us know in the Discord chat room. Some of us from the NOSP board are there and would be happy to discuss with you what kind of options are there. We're also accepting nominations for board members for 2021. Speaking opportunities at any of these 3 upcoming events. Let us know if you want to speak. And one final plug for these fantastic Get Kids Into Survey posters that are so wonderful and big and huge and available for anybody who is still homeschooling their kids at home and would like to get one. Reach out to me on Discord and I'll get your address and send it over. So with that in mind, today we welcome Mike Gallo and Ben Leslie from Ravco. They're calling in from Edinburgh and Bristol, as I understand. I will bring them right into the chat. And I'll see you again, Simon, at the end of the show. Let's see what we do. Ready?
Yep.
Mike and Ben, welcome.
Hello. Good evening, everyone. Thank you.
Hello.
Thank you, Selena. Thank you, Simon.
Yeah.
Thanks for the intro.
Yes. Mike, I'm missing your screen. If you go ahead and share it with me, then I can
Yeah, sure.
put it up there.
Also waiting for this, I'll just say, yeah, my name is Ben Leslie. I work for Rovco. I'm a senior computer vision engineer, and I am the technical lead on one of our Innovate UK funded research projects. And I'll be here to help answer technical questions you might have about any of the nice things that Mike's talking about this evening.
Excellent. And so what I think will happen is that probably both Ben and Mike will be available in the Discord room after their talk to answer questions. But if you would like to ask questions that they can answer kind of live on the air here, use the channel that's called Questions to the Presenters in Discord, and I will then field them in at the end of their talk. So use it actively, ask them questions, and I will be happy to pass them along to our great speakers. Okay. Take it away, guys.
Good stuff. Thank you very much. So, yeah, saw that Ben already introduced himself. So, good evening, all. I'm Mike Gallo, Technology Business Development Manager at Rovco. So, I'll probably start with a bit of introduction of Rovco, where we are and how I actually joined the company. So, Rovco, you might know Rovco as a service, ROV service company. So, as a company, they started in around 2016, 2015, 2016. And yeah, the objective is basically be a service company, ROV service company. They developed some, started developing more technology initially as a differentiator for their own services. Then at some point last year, as the technology matured and the technological direction shaped up in a better form, there was an understanding that there actually is a better potential for the technology to succeed if it's also commercialized externally, just because it could reach, give the company much bigger reach if it's commercialized externally as well. So that's where I come into play. So I started the company about February time. And here I am, 6 months' time. So I'm based in Edinburgh, and my colleague Ben is based in Bristol. Bristol remains our headquarters, whereas Edinburgh is going to be our next operational base, just to keep us. It works from a services point of view, but also works from a technological point of view in terms of attracting talent to take our technology to our next stage. So. Okay, with the introduction, so what I'm going to be talking about tonight is this evening actually is what about our technology, our products, and our offering, and basically what's our direction. So our direction is to achieve a truly autonomous survey. What we mean by truly autonomous is using subsea robotic system that go on their mission with full knowledge of the environment and some sort of level of independence or control, and they are only supervised from shore. They're not remote controlled from shore. So that's the end goal for us. Obviously, to reach that goal, there are some founding blocks that you need to put in place. And these founding blocks are some of the products that have created basically our technological offering. These are technological products that will take us to the end goal, but obviously, while we reach that end goal, they are able to deliver benefits as of now already. So the first point that we start with is SubSlam. So SubSlam is the first point that you need to do to enable robots to have visual awareness of the space is to substitute video with 3D data. So that's what SubSlam does. It creates a 3D point cloud in real time, and it's both an imaging and positioning system. So another thing that's important is that if you want to give a robot awareness of space, you want to rely on less system, make it more streamlined as possible. And that's how our SubSlam is both a positioning and imaging system. Obviously, it doesn't only deliver the benefits for robots, it also delivers benefits to us. So using a 3D point cloud, 3D point cloud is a more objective way to have an estimation of space and do inspection of structures. And the level of precision that we acquire is actually in the middle beta region. So I'll be specifying more of that later. So we don't need to use any positioning system to create our 3D point cloud. So no USBL, no LBL, no INS. So The calibration is a straightforward 10-minute exercise, so we don't have to spend half a day or a day calibrating positioning. And the live 3D models, like I said, the millimeter level of accuracy. The live 3D model has a 16-20 millimeter accuracy, whereas when you post-process the model, you can actually reach sub-millimeter level of accuracies. We don't need to place any sensor or scale bars on the object, no images or QR codes and all. So we can just, the system just recognizes features independently. And we can stream the data over VSAT. So I'll take you through. So that's how the system works. In an example, so that you see has generated a 3D point cloud in real time. You can see all these pink crosses on the lower on this corner here. So these are basically all the features that are being used to track the model and to stitch that 3D model in real time. You'll notice at some point the model will kind of move about, jitter about, and adjust itself. It's not a bug; it's actually a feature of the system. One of the things that we have achieved with the SubSlam is the loop closure. The loop closure is when a SLAM system builds a 3D model, goes on features it's previously observed, and by that, it gets a better sense of space and position. And by doing, and at that point, it has a chance basically to address any positioning error that's been accumulated over time. So by doing that, it understands, okay, this is where I am, this is where I'm going. And it fixes any address. So it ensures that the 3D model stays correct, and it stays correct over time. So there's kind of a dramatic example here of loop closure. So this means that we can extend the capability of the system over larger structures. Okay. So systems, obviously, we are always working to improve our systems and doing a lot of work on that. Ben and et al. Are working hard improving the system. One of the recent breakthrough of the system in the system, this is going to become available in the systems that we're going to build in 2 or 3 months down the line. So it's basically fast SLAM. So in this example here, the vehicle has got thrusters at max velocity. So it's to simulate kind of like a rush of current or any being hit by an object and being stranded off its course. So what you can see it's happening, we're actually we still keep modeling the 3D model. We're not losing tracking. Even if we lost tracking, it wouldn't be the end of the world. It means that we just need to go back to a feature we previously observed. But this means that we need to be doing less and less of that. And it means that we can be faster to achieve a complete model during our inspection. Okay, so, and yeah, so in terms of the accuracy of the system, we've done some tests. Like I said, the real-time data set has got an accuracy of around 16 millimeter. When we post-process the data, we can then take it to a sub-millimeter level of accuracy. The advantage, obviously, of having a real-time data set means that we can have an estimate of the data, that how much space we have covered. So we have that confidence to leave site, knowing that we have covered enough data. But also what it means that we can budget our post-processing. Maybe we don't need to have a high sub-millimeter level model for the whole structure, and we just want part of the structure to be post-processed. So that makes the overall process a lot faster. So what we did in terms of measuring the accuracy, we did the trial in a dry dock. We placed a subsea connector in the middle of the dry dock and did measurements using a terrestrial LiDAR. Then we did the same, and that's an exercise that took about 2 hours for this connector. Then we did the same, mounting the SubSlam on ROV, and we inspected the connector and acquired a 3D model that way. So we saw that actually, by comparing the 3D point cloud, we had the accuracy was actually similar, with an average of plus or minus 4 millimeters and an error of 1 meter of 0.67 millimeters. So this test was actually carried out about last year. And we are confident actually that with the newer systems that we're building, with the improvements that we made both on the hardware and software, when we go and do this test again, which we're planning to do soon, we're going to actually achieve better results than what we achieved here. Okay, so these are some of the examples of what we can achieve when we post-process the data. So the 3D model gives in real time gives us a 3D point cloud, and when we then do post-processing, we use photogrammetry techniques using the base data of the subslam, and we can basically add that mesh layer, giving us that photorealistic element. So what we can see here, that's a jacket inspection. So you can see actually a good view of the risers. We've used this the system actually for riser verticality inspection. The system is suitable for that kind of work as well. And that's another example of a tripod being expected, tripod structure being expected with the subslam. So here are some of the examples. There's a lot more. There's a Sketchfab page of Rovco, and you can see a series of 3D models. So if you go on sketchfab.com/Rovco, you'll be able to find more of these. So okay, so going back to autonomy, right? So we're talking about a system that can see an image in 3D. It gets awareness of space thanks to the subslam. It gets awareness of position thanks to the subslam. But now you need to send all that data back to shore. How do you do that when you're working with the BSAT? What we are doing is we're not sending every pixel that's getting generated offshore by the subslam, because at that point we'll need megabytes of bandwidth, right? So what we're just streaming the XYZ and RGB value of the 3D model. That model travels over our digital platform and gets reconstructed at the client's end. So first of all, we don't need to install any software on our PC. This is all browser-based. And it means that it can travel over an upload bandwidth of 150 kilobits per second. What the user on the other end gets, and which is interesting in this COVID age, so this is now a person, can be a supervisor that doesn't need to be traveling to the site, and it can be just from the comfort of his own home and look at basically the progress of the survey, and you can see what's been collected so far. Potentially can sign off and say, yeah, happy with what we've collected. You can take some preliminary measurements and do initial assessment of what's been collected so far. Okay, so this is all from a subslam point of view, and then you've just seen the digital platform, and that's what we have. So our digital intelligent data platform is going to be actually the centerpiece going forward of all our offering. So digital platform is at its core a data repository tool. So it works on a GIS interface. You see all different assets here. So you can click on an asset, and by clicking on each asset, you can see what any survey data that's relative to that particular asset. So this could be historical data that's been collected, for example, or just the latest survey. So you have an easy access, intuitive access to the data that's being collected. So this is something that we're offering to both operators and contractors. So you see the Rovco logos on, but we can custom make it and white label to suit needs and also get some custom requirements in. But what we also have here, you can take video data and you can also upload point clouds. And again, you can also get the live streaming of the data of the subslam if you're using one. But this is a segue to what's our next stage to enable autonomy, which is machine learning. So the idea is that you'll be able to have a survey footage that's been taken using any camera system, doesn't need to be the subslam. You upload it to our system, and then you take it through machine learning. And so we're starting from pipeline in terms of proving the technology, but the aim is basically to expand its capabilities to any type of structure that's subsea. So this is what you can generate. You upload your video, the computer goes through it, and you spit out a report with all the eventing. So the aim is that a human being doesn't need to spend hours eventing pipeline footage, but a computer can do it instead. So we're taking kind of a novel approach with our machine learning. So everyone seems to agree that machine learning is the future, right? But how come no one's using it though? So because basically there's some time required for the machine learning to become as good as a human being. So that creates that level of distrust, because everyone wants something that's ready, it works today. So no one's going to give machine learning a chance to get to that point. So we're kind of a chicken and egg situation. So what we're doing instead, we're putting the human back in a loop, and we are using the machine learning system to speed up the eventing phase. So what you see here, it's an interface that the video gets broken down into segments. You see all the segments here. At the basic level, the operator can select all different tiles, and it can associate them to a particular event. So you see, once all the categories are created, you can get the categories coming up in your screen here. So for example, we have created an adult category. So that's at the basic level if you're doing it manually, okay? You're still saving time because you don't have to watch hours and hours of video. Also, another thing that's useful, for each tile, you have a link back to the original video. So this could be used also for further inspection if you want to go back or do a more thorough assessment of that particular event. So you have an easy link back to that particular event. So that's where it gets interesting, and we'll be using machine learning. Now, we are using the machine learning capabilities to sort the images. So we're just done a sort by outlier, which means that we're going to be sorting the images by anomalies. So show us anything that looks very different to a normal pipeline. And you see it's bringing up these matrices. So we're taking the matrices and we're logging them in the matrices category. And you see that the matrices being now categorized. And again, pick another matrix, which is a different type of matrix, a flexible type matrix. And we now sort these similarity. So say, show me similar images to this. And you can see, show me all the types of domains for similarities. And we assign them again to a matrix label. And we have now more matrices in our matrices. And again, do another outlier search, and you see other features. We found an anode. You see the probe on the anode. Say, show me more anodes like this. You see, and that's how I can see all the anodes, and I can event my anodes this way. So that's how it works. So what we're doing here, obviously, this is we are actually training now the machine learning to become better. We still have a say in what's happening. We don't have to, trust the machine learning to do a good job. We are actually teaching machine learning how the job is done. And at the same time, we're actually saving lots of time because we're not watching hours of video. And with time, this is going to be less and less required because we can just obviously just ask machine learning, hey, show me anodes, show me matrices and the likes. But so this in time will be less required, but at the same time, we still have that peace of mind step that we have a way to go back and check what's happening, what the machine learning is looking at, and possibly making changes if the machine learning gets tweaked, needs a bit of tweaking. So this is where the starting point, and it's a good starting point for us because the system that we built also scales up very nicely to also go beyond pipelines. So could we think of site characterization, for example, habitat mapping? Could we think of jacket inspection? Could we think of anode inspection and depletion? But another thing that we're going back to, how do we make robots more intelligent and take over the survey world? What we are doing is freeing up space, computing space on the subslam, and enabling machine learning to work at the edge of subslam. So subslam, typically, the positive thing of subslam is that you can do a 3D reconstruction at the same time as you're doing a general vision inspection or a close vision inspection. So you're doing two things at once. You're not just mobilizing for that 3D model. But now, if you also enable machine learning to work at the edge, as you're going through your inspection work, you're actually recognizing events and tagging them along. So all this thing, it will eventually become automatic. So that's the future, the near future development that we have. And the next thing, going back to subslam, as we are now moving towards the future, is using the subslam capabilities for allowing remote control of a vehicle. Actually, should I say truly autonomous control of the vehicle. So what we see here is capabilities of the system to suggest, you see these red pointers, the system is telling us, first of all, the subslam is allowing the vehicle to station keep on its own. And the system here with these red pointers is suggesting areas that need to be further explored whilst it's in an environment that it has no previous knowledge of. So system goes down, has no knowledge of where it is, looks at the features and say, okay, this is where I'm at. This is where I need to move next to complete my inspection, to complete the inspection of the environment. And if you think that machine learning will be at the edge, if it spots an anode, if it spots a piece of marine growth, it will tag it. It will tag that event and add it to the mission. So next stage towards this, and that's the kind of project that Ben's working on, is enabling autonomy. So next stage will be operator subslam station keeps the vehicle. Operator clicks on an area, or and the system goes to the area, or actually the system, which will be the next further stage, just goes down, has a knowledge of space, and knows where it needs to go to complete that inspection. So that takes us to what our future vision is. So everything will be controlled by the digital platform. The digital platform controls all your vehicles and manages your data sets, your deliverables, as it can do already now. And the vehicles will have subslam and use the positioning and 3D reconstruction capabilities of the system to scour the scene and to know where the vehicles need to move next. And at the same time, the machine learning will collect all the events. Everything then will be sent back to shore. And again, from what we're doing back from shore, as the robots are intelligent, we're just monitoring that everything is going well, and we'll be intervening if anything goes wrong, but we're supervising more than controlling. But yeah, so to bring it back to today, I'll say, talk about today soon. So like I said, there's a future vision that we're making a reality, but what we're building to make that the future a possibility is it can deliver results today. So subslam is a very swift 3D real-time imaging and positioning system. And it's a very useful tool for metrology application, for example, because we can get a very accurate data set in real time. We don't need to calibrate. We don't need to spend days calibrating, taking different measurements. We can build that 3D model real time. UWeld inspection is a big plus for us as well, because now we've done all of, for example, chain inspection using the subslam system. And again, for the machine learning side of things, is pipeline inspection today, but then the future is having a machine learning toolset at the edge of subslam. Actually, probably there's also an interim stop there where machine learning actually can do more than just pipelines, and can do also other type of structures and other type of activities, like, for example, site characterization. Okay, and then also subslam also has some good civil application, and possibly also UXO and military type of inspection. So that's what we have. So hopefully it was interesting to you. Thank you everyone for the patience. Hopefully it wasn't that PowerPoint. Yeah, any questions?
Yeah. All right. Thanks, guys. Yeah, I got a question from Walter, who asks, what work has been done to bring this relatively positioned imagery into a real-world coordinate reference system to allow integration, visualization, and analysis with other external data sets, for example, in a GIS?
Yeah, so there's actually a slide that I didn't bring up in this pack here, but we have done, for example, inspection where we integrated the data set from subslam into other data sets, for example, multi-beam. So where there's an image of a monopile integrated with the multi-beam bathymetry. So yes, the point cloud is relative, but if we have one known point inside the structure, we can basically use that coordinate to translate the relative point cloud into an absolute point cloud.
Awesome. I have a question myself. I was thinking to myself that the imagery of the mattresses is quite distinctive. So I guess my question is, are there some types of events that are easier to classify than others, or that you have a higher failure rate on identifying?
That's a fantastic question. Thank you very much, Selena, because it's something that I miss saying. So, so one of the things, actually, one of the limitations of machine learning systems is that you can tell them, you can easily teach a machine learning system to detect something that's repetitive and common. So if you need to teach a system, okay, this is an anode, show me all anodes. It has a lot of examples on any data set to see anodes. And you can classify them a bit easier. So what we do instead, by using sorting criteria, we can basically ask the system, show me anything that doesn't look like a normal thing, so it looks more like an anomaly, and that's how we can bring up things that are probably unclassified, things that, and how we can also better perform on data set that hasn't seen before. So we're trying to, that's why we're also bringing the human back into the loop. So because we have good confidence in terms of like picking up anodes, field joints, and these type of common features. But when you want to bring up things that don't look like the normal thing or damage, something that needs to be assessed by a human being, we are using the machine learning system to take those away, so to show them up as a priority, so that we can focus on them, and giving the human the chance to assess what those weird and wacky images are and classify them based on their intellect.
I've just noticed that there's a follow-up question to the integration with other data coordinate systems. So yeah, you're right, 1 point isn't enough. We need a point and an orientation or a line. But actually the 3D data from SubSlam is already at true scale because we've got the stereo system. So we don't need anything to tell us the scale, but yeah, we do need an orientation.
Let's see, we got another question here. Can SubSlam system be installed on resident ROVs?
Don't see why not. So the system is actually quite easy in terms of requirements. So it just needs a 24V connection and 100 megabits Ethernet connection. Probably thinking of resident ROVs is thinking something that stays underwater for a long time. So that's probably something that we need to test, I think. But Ben, do you know if we've done any testing in terms of like long life underwater for the casing?
No, I don't think we have done that. But I can't see any reason why there should be any difference between, a 48-hour synchronization and a 480.
Yeah. So, hopefully that answered that question.
One more question. How quick to mobilize?
So it's pretty straightforward. So as long as Ben, you can always take us through that. You've done it maybe many times. You probably have the workflow in your mind.
Yeah, sure. I mean, so I did an ROV integration on Monday afternoon. It took about 2 hours, something like that. It's really not a difficult thing. We just need power and data comps in the ROV to send the data up the tether. When you first put the system in the water, there's an in-water calibration procedure. That's actually something that we're eliminating as one of our research lines. We've demonstrated it in trials. It's coming to the commercial product soon. So you'll be able to replace those in-water calibrations with an in-air calibration, which is going to save everyone a bit of time. But yeah, I'd say mobilization is very quick. There's no long setup procedure as you get with things like USBL, where you're having to do all the dimensional control and stuff like that on your boat.
Great. All right. Well, Walter says, thanks. Very interesting presentation with a thumbs up, which I think everybody can agree to.
Thank you.
Have more than 50 people watching the live stream now and almost 30 in the chat room. So we're doing really well on the viewer side. Appreciate very much all of you who are joining us live. And of course, those who choose to watch the stream later are also very appreciated. Okay, thanks guys. If anybody thinks of any questions that they didn't get a chance to ask now while we were live, both Mike and Ben will be in the chat room, I'm sure, through the end of the event and can be contacted there.
That's great.
All right, thanks guys very much. And it is my great pleasure to welcome Dan from Aberdeen and Fugro.
Good evening all.
Oh, your sound's no good, Dan.
I should be unmuted. Can you hear me?
Yep, I can, but your video and sound are very out of sync. It wasn't like that not so long ago.
Oh, sorry. Is
Try
that
again.
okay now? Technical glitch. Can you hear me okay?
I mean, the sound is perfect.
Right, that's a shame. Let me just try stopping the camera. Has that improved things at all?
Okay.
You can
Your
hear me
sound
though.
is perfect.
It
Your
was
sound is
working,
perfect.
wasn't it? It was working okay half an hour ago.
Was. But you know what? It doesn't matter because you're going to talk to yourself. So I'm going to stop talking. You're going to talk. I'm going to put up your screen. It'll just be that your mouth doesn't move together with the sound. But the sound is otherwise. Okay.
Apologies. I'm not sure what's happened.
It's back now. It's perfect.
Okay. Right. Good. That's
Take
excellent. Yeah. So apologies there for the technical glitch, everyone. Good evening. Just to briefly introduce myself, I'm Dan Jones. I'm the IRM Business Development Manager for Fugro in Aberdeen. A bit about my own background. I've been involved in subsea offshore inspection since 2003. I worked for Fugro during the period sort of from 2008 through to 2014, but I've recently rejoined at the beginning of this year. So I have joined the business at a challenging time. Obviously the COVID epidemic has changed the world we live in that time. But in terms of where Fugro are, I'm hoping to just discuss with you this evening the journey they've been on, the technological shift that's occurred within our industry. And I'm going to discuss some of the projects we've worked on recently where we're trying to conduct, well, we are in fact successfully conducting subsea inspection and survey operations offshore using remote and autonomous systems. So hopefully I'm coming through loud and clear now. Just a brief overview of the contents, so you kind of know what you're in for. I've obviously introduced myself, give you a brief overview of our remote operations centres. They're global operational centres, and a demonstration of what we now have within our Aberdeen office. Some further case studies, a recent case study on a platform inspection that's been conducted remotely in the North Sea, and then some further case studies on our various other survey capabilities and remote operations in other capacities. I'll also then discuss our unmanned surface vessels. This is something some of you may have seen in recent press releases on social media and recently on the BBC, in fact, and our future developments in that regard, and where we see the industry naturally developing as we increase our capabilities with unmanned and remote systems. So, as I say, Fugro have been on a journey, and approximately 5 years ago, they established the Remote Operations Centre in Aberdeen, as well as in the Perth office in Australia. Our goal is to be global leaders in the provision of remote and autonomous offshore survey inspection provision. We're still on that journey. There are still lessons being learned on a daily basis, but I'll demonstrate our current capabilities and also our expectations for the future. One elephant in the room, one thing that's always asked of us, and I don't want to preempt questions, is will the provision of remote and autonomous systems mean the reduction in skilled personnel requirement? And the answer to that often is no, it doesn't. Many of the processes and the applications that we're looking at mean that we still need skilled people. We still need the capability and the experience that these people have to offer. We're often talking about maybe moving them from one environment to another where they're no longer offshore, they're no longer away from their families and friends, but they're able to access the data and the inspection and survey capabilities that they would previously have had to visit the offshore site to achieve. So a bit of background to Fugro and where we are now. We have global coverage with remote operations. We have 8 global centres, 8 locations now. They have differing capabilities. So the ultimate capabilities with remote survey, remote processing, remote inspection, and remote ROV piloting, at the moment, those capabilities are restricted to the Aberdeen and the Perth offices, where we have full office-assisted remote services, back-to-base video streaming. This is principally at the moment down to bandwidth capabilities and the communication systems that we see in those various regions. But as we get more traction within the other geographic regions, we expect to expand this offering, and ultimately the plan will be to have full global coverage with our remote operations capabilities. So I've got a very brief video here. This hopefully particularly has been set up during the COVID restrictions. Gives you, hopefully this comes through okay with not too much glitching. This is a tour of our remote operations centre in Aberdeen. We consider this a state-of-the-art facility. We're able to offer, as I say, data processing, satellite positioning, remote ROV piloting, and inspection and survey from this centre now. We have 4 purpose-built rooms for remote and live operations. In addition to that, there are client spaces and offices that clients can visualize what's going on in the offshore environment. And one of the things that you'll see is that the whole ethos of it is to make it a very friendly, adaptable place to work. Very different perhaps from the ships that some of us have been used to working in or the offshore installations we're used to working in. Additional to that, we very much view the future as a transition from those operations from offshore to onshore, and we're able to offer construction and decommissioning support. And basically, we feel a faster and more flexible workspace in which to conduct operations. Obviously, one of the key things we're able to emphasize is that during the COVID epidemic, this means sometimes we're able to put less people in harm's way in an offshore environment, and we think that demonstrates that the centre definitely has a bright future. One of the ethoses that runs through Fugro at the moment is that we feel it needs to be, it's a change of thought process in some respects for the industry, that the remote operation centres, we call them, conversely are actually the local centres. These are the offices near where people live and their families are based, whereas it's the offshore work site that's the remote location. And I think this statement tries to encapsulate that. To give you a sort of a rough idea how the process works, this slide has been sort of widely publicised on other presentations, so apologies if you have seen it elsewhere, but it does give a very clear sort of an indicator of how we see the remote operations process working and how that helps our clients and helps our workforce achieve their goals. Obviously, we have an asset offshore, whether it be an oil asset, a platform, it could be a subsea installation or a pipeline. We're out there gathering data. We're maybe using an ROV, an AUV, or a fully autonomous remote system. We have a variety of sensors and imagery that's acquired in this remote location, and we have a base. We have to obviously transfer that data back to base. We've spent a great deal of time developing the systems for making sure that we maximize our bandwidth utility, that we have compression algorithms, we have systems where we reduce data sets to the minimum so that we're maximizing that. One methodology that we use when we're using Sense, which is our autonomous pipeline processing system, which uses machine learning algorithms, a little bit of overlap perhaps with the Rovco type developments, but I think fundamentally different in its approach. we bring that back to the cloud using sort of Amazon web-based services, and that is accessible then to onshore. And additional to that, we can separate, we can split the data set. So if we have a remote ROV piloting ultimately, but certainly remote inspection, that can be conducted in our remote operations center, but we're not sending the data indirectly. We can split that off and send it direct to reduce latency, to reduce the lag in the video, and this enables us to do a single hop connection to the ROC, and reduces any sort of downtime and difficulties with that data transfer. And then ultimately, we have a delivery process. We'll highlight that you could be working from home. We can offer remote desktoping based in the cloud. So it's not even necessary anymore to have high-powered PCs for that processing. Much of that heavy lifting can be done with cloud-based resources. So just to demonstrate where we are in terms of immediate access to data for our clients, this is just again a very short video section. Hopefully this is coming through. This is the level of detail we can provide to our clients within 1 to 3 hours of the actual acquisition. Although it's referenced as Rome's there, that's been rebranded recently within Fugro as Sense pipelines, and we have a process where the data is decimated, is reduced. So the video that is sent back is obviously with lower frame rates, often of crystal clear quality, but again compressed to make maximum use of the bandwidth. And the same is true of any multi-beam or additional data sets that are required offshore. But we think this is a fabulous way for clients to get immediate visualization of what they've got offshore. But also, if necessary, they can bring in their own technical authorities or other expertise to see this data whilst vessels are still in situ and they still have access to their client reps and whatnot offshore. Ultimately, we see many benefits. This just outlines some that we're keen to highlight. I think one of the key things that I've mentioned and touched upon already is that the risk mitigation by removing personnel from offshore, we're taking them out of that harsh environment, that environment also where they're away from family and friends, and we're bringing them to a far more secure and scalable operation in an office onshore. Also, with the additional speed with which we can deliver data, we're giving the client that reassurance, that surety that their project is going to be up to scratch, that they're getting the deliverables they expect, and we're moving the delivery of some of this data from what used to be weeks or certainly days as a minimum to now a matter of minutes or hours. Client cost reduction can certainly see things that will reduce their costs, but often this is by virtue of the opportunity costs. So they're gaining bed space, they're getting their project delivered in a remote manner, means that they've got other provisions that they can focus on. And also the flexible and scalable nature of the operation means that if, for example, you have a period of downtime on weather, we can refocus our personnel in the ROC to maybe work on other projects or catch up on reporting, whereas this is not necessarily the case if a vessel is in field and just on that project, for example. One of the other things that these operations that I'll lead on to when I talk about our unmanned surface vessels is the significant reduction in carbon footprint. So obviously by reducing travel, and we're talking about helicopter flights and plane flights for personnel around the world, but also by reducing the size of vessels and their natural fuel burn, we can reduce carbon footprints for the type of operations our clients are dealing with substantially from current DP2 class ROV vessels, for example. So I'm just going to go into a few case studies. These are just short examples of recent achievements. Some less recent, even dating back to 2018. Currently now, a figure that was established in January this year, we've over 150,000 hours of remote operations globally throughout Fugro, and that's a figure that's probably substantially greater than that already, given that was based in January. So one of the case study examples that we completed this year is an inspection of the Orc platform. That's 250 kilometers east of Aberdeen. That was done with inspection engineers based in our remote operations center. And we've recently completed a campaign with Enquest on a similar remote inspection campaign where the personnel were largely based in the remote operations center. Obviously, this reduces the number of helicopter flights and the potential exposure to hazards that those personnel may be exposed to. So I guess going back a step in terms of how we got to this capability, we've spent many years of trial and error, of learning through doing, making sure we have the right encoders, the right video systems, and maximizing bandwidth and comms. It is relatively straightforward if you've got enough bandwidth. It's a lot more difficult if you're restricted by VSAT comms or the 4G connections that we can obtain in certain regions, but they're subject to various constraints depending on the platform or the asset's location. In terms of planning for a platform-based inspection, obviously we're very restricted in terms of space, and in terms of cabling, even on a platform, that can be difficult. And obviously the goal here was to achieve remote visual inspection, including cathodic protection and flooded member detection, FMD, and all via a remote system. We found that a minimum of 4 meg per second connection was required. This is achievable within the regions that we're discussing. And although initially we'd intended for these earlier projects to be test systems, if you like, to ensure that the capability, the COVID-19 crisis meant that many of our customers couldn't maintain the level of manning on the offshore installations that they'd hoped. So we really were restricted in terms of bed space, for example. So it became a live requirement as we built up to these projects. Ultimately, in these examples, we mitigated problems for our clients. We made sure that the projects were completed on schedule and in good order. Undoubtedly, schedule delays could have had a substantial financial impact for our clients if, for example, they had to utilize an ROV-SV, which would have come at greater cost. The clients ultimately were very pleased with the results. Again, I think I've mentioned quite a few times the reduced risk for personnel exposure, and again, particularly during the current crisis, by reducing the number of personnel that we have to place offshore, that's been a massive coup for many of our clients here. One thing again that also is can't be underestimated is that having that instant access to the data for the client gives them the opportunity to assess the status of their assets in real time or virtually real time, depending on their level of interest, and particularly if there are anomalies found or significant findings that might be critical to the safety of the structure. This is the kind of information that this provision will give them immediate access to. Obviously, as well as that, it's come at a time where positive media exposure is undoubtedly a benefit to all businesses. So, this was feedback we had from one client earlier this year. They were happy that we'd achieved a project under the constraints of COVID and on time. And gradually, we expect more and more operators to look to conduct these kind of operations remotely in due course as well. Historically, we developed this original provision last year. We did some work with SSE at the Beatrice field, also obviously in the North Sea, but a little bit closer to shore. That gave us some capability with standard 4G data networking. That obviously gives us much more bandwidth than perhaps we're used to with VSAT, for example. And we're able again to complete a scope of work that included marine growth survey, FMD, GVI, and inspection of the jacket structures, as well as some survey multi-beam scour surveys, all remotely. Further back, and also not requiring ROV provision, but vessel-based, using crew transfer vessels, we'd been developing our ability to process data, again, in near real time, with wind farm inspection, scour surveys, and multi-beam inspections over in Denmark. Again, that was completed with 88 sites covered in a 6-day period, without the need to put those data processors and survey personnel on those vessels, which have restricted capacity, obviously. So I guess moving swiftly on to sort of our vision for the future and where we're heading as an organisation. We've had some recent press coverage, which many of you may have seen. Just this weekend, in fact, the BBC had an article on the Max Lima. That's a 12-meter unmanned surface vessel. It was the winner of the Shell X Prize last year, which again many of you may be familiar with. Fugro have been heavily involved with the development of this vessel. We have a collaboration with Seakit. That means that we're going to be taking delivery of a couple of these in the next 6 months. These will have the capacity, obviously, to launch AUVs. And I suggest that if you get a chance to check out the news article in the first instance, that might give you a bit of insight into the capabilities of the vessel itself. But to highlight these vessels that we're taking delivery of will not only have AUV capability, but will also have observation class ROV launch capability as well. So our vision again is that these can be used in environments that currently require an ROV SV, that are offshore and out of sight of land. So this is over the horizon technology. These can be driven and controlled from our remote operations centres, currently in Aberdeen or Perth, Australia. Again, similar benefits, probably reiterating these once too often here, but the saving and the risk that's removed from the personnel, and the improved work-life balance that having them based in the remote operations centre yields can't be underestimated. The sustainability elements are absolutely key to our vision for the future. All our clients, oil and gas clients in particular, are heavily focused on reducing their carbon footprints and removing the need to mobilize large-scale ships that are heavy fuel-burning vessels often, to go to much smaller vessels such as these USVs will give them real benefits. As things have progressed, we are trying to spread this message to help shape the future of the industry and the way that it's perceived. We do see it as a change in thought process for some operators. Many oil and gas operators in particular have perhaps got very used to traditional working practices. They've developed those over many years, and they've been proven to work. So there's a reluctance, perhaps even a resistance within some organizations. We do see, particularly at the exec level, when we engage with operators, that they're very keen to see where this technology can take them. At the moment, particularly with the recent oil price crash, there's maybe slightly more resistance at supply chain level. And again, for us, it's just educating and highlighting the many benefits that it can bring to their organization with our customers, when we're offering this service, which is ultimately a different way of doing things. And that's naturally going to take time to change within our industry. So it is worth highlighting, though, that some of our biggest customers are those that are the ones pushing for us to make these changes. There's been a drive for us to make more things more sustainable, to reduce our carbon footprints, as said, to collaborate with our customers as well. And ultimately, companies such as BP have been very clear in their mission statements to push all subsea inspection and survey operations to an autonomous level by 2025. Obviously, with the recent COVID situation, that may be difficult to achieve, but we believe we're still on a path to achieve that, and aligning our own strategy within Fugro towards the Maritime 2050 expectations that we can achieve everything remotely and autonomously in the future. This is again my final slide. It perhaps shows where we came from, where in 2017 we didn't have any remote operations to our clients, and in 2018 through to now, we're seeing increasing numbers, both renewables and oil and gas customers that are very interested in these technologies to assist them with their data acquisition and processing and reporting capabilities. I guess I shall leave it there. Hopefully that's given you a very quick idea of Fugro's vision for remote and autonomous acquisition in the future. By all means, feel free to ask me any questions that you may have. I will do my best to answer them, but if I can't, I'll perhaps have to engage with one of our resident experts and get back to you on it. But
great, thanks, Dan. That was fantastic, and I can confirm that the problem was on my side, not on your side. I got snowed under by comments from people saying it's fine on the stream. So sorry for stressing you out about the sound.
No, that's quite all right. That's quite all right.
Yes. All right, Dan, we've got some questions. Let's see. Elaine says, how much of this could have been done pre-COVID, meaning that the tech was there? I mean, you did describe some things that had been done in 2018, so I assume the tech was there. But she says, but the operators maybe weren't willing to take the leap. Has the current situation been a nudge to do more this way?
I think the true answer to that is absolutely yes. Operators, by their nature, tend to be quite conservative, and they're not necessarily particularly in supply chain management, they're not always keen to take the risks. And I think they see this technology, they like it, they were willing to engage with it, but they weren't necessarily willing to sacrifice an operation, not sacrifice, but to take that risk, to actually be the first, if you like. And obviously certain situations arose with COVID where we couldn't even mobilize personnel to platforms on certain occasions. And that meant we had to find an alternative way. And as it happened, we developed this, and it was the perfect opportunity to demonstrate it. So yes, in a sense, there's not much that's positive to perhaps come out of the current global situation, but this might be one thing where it's pushed this, I guess, in a similar way to the world that we all live in. We've all developed the ability to work from home all of a sudden, and that ability was probably there, but it's just maybe the driver to get it done sometimes, isn't it?
Absolutely. Let's see. Walter says, I think several operators are very keen to implement this technology and are actually pushing this harder than the supplier domain, because some more traditional existing suppliers are concerned about their existing real estate, that's vessels, rapidly becoming obsolete, and would prefer to push existing systems in the market.
Yes, so no, thank you, Walter. I would tend to agree with you. I think that they're like any new technology, it's not just the customers that have to be willing to engage with it. It is the suppliers, isn't it? Ultimately, though, I think there's two sides to that. That whilst operators and the clients therefore are keen to see this technology, they're not always willing to maybe share some of the risk that's required in terms of the costs. Obviously it's immensely expensive to invest in these new technologies and to develop something to market which doesn't necessarily have a proven sort of sale value to the supply chain. And I would agree that there's resistance in both sides, but I think if there's true engagement from both parties, it can actually be beneficial for the whole industry. Where I think it's also worth bearing in mind that this is maybe an addition to, as well as not rather than just supplanting all vessels in the long term. There are naturally going to be limitations, certainly in the short term, by virtue of the size of the remote operations vehicles that we can build and that we can operate. We're not necessarily talking about the removal of all ships from our offshore sites, but yeah, I think that's probably a fair comment, that there's some hesitance on both sides.
All right. We have a question about the bandwidth requirements. What would be the typical VSAT bandwidth requirement for remote survey and or remote ROV piloting? And how can VSAT dropouts be managed for such activities, especially for the case of ROV operations from moving vessels?
Yes, so there still are some ongoing developments in terms of remote piloting. So I think we've definitely reached a point where when we have TAMPnet or 4G availability, the provision for remote piloting is certainly doable. Through VSAT, there are limitations. We do need increased bandwidth for that. I think in terms of video streaming, we really require about an 8 megabit per second connection. It can be less for just remote survey. So I believe the minimum requirement there is 2 meg. But again, depending on what we're trying to achieve, it does influence the bandwidth, obviously. In terms of comms dropouts, that they are unfortunately an inevitability when you're using these things. But obviously, we are developing the systems and the safety protocols, the fail safes, if you like, so that when they occur, vehicles will return to base, effectively return to TMS or their launch position, and in due course, that they will be the things that we will just have to rely on when operating any vehicle remotely. And again, we're at the forefront of developing them and ensuring that our operations will be safe, whether they're controlled remotely or locally in the same way.
Excellent. There's also a question here about the configuration you have on shore, if it allows for the presence of a client or technical rep rather than them sitting offshore, being a further reduction in carbon and HSE footprint.
Yeah, absolutely. So a recent project we've just completed, we had the technical representative in the remote operations centre in Aberdeen throughout, given their own dedicated office, subject to social distancing, obviously, as things stand with the COVID restrictions. But yeah, they were there and they were able to see the operations live as they occurred and communicate with the guys that were conducting the inspections, who were in an office literally just through a sheet of glass. So it definitely, I think, in truth, I haven't got a statement from them as yet, but we expect them to give us a very good bit of feedback on that recent project, because they were maybe skeptical at the beginning themselves, but probably considered themselves converts by the end of the first few days, where it was proven to be working, and they felt as involved as perhaps as if they were on the asset offshore themselves. So.
And it's a bit like you said about the COVID situation, that we probably could have been doing all this, but people weren't really comfortable. And just like Teams meetings and Zoom meetings and whatnot, people were maybe a bit resistant at first, but then they figured out that actually it was works quite well, and you get to sleep in a little bit longer in the morning.
Maybe, yes. Yeah, no, I'd agree.
Well, let's see. I think that a follow-on question. Does this because we're a little bit out of sync with the questions and the stream? I'm not exactly sure what Elaine is referring to, but she says a follow-on question: does that change how contracts are set up, incentives, and deliverables? It might have been from a few sentences ago that's a follow-on up. Can you?
Yeah, yes. I mean, there are commercial elements. Every contract obviously is different, so it's impossible to be too generalized with this. But we have to acknowledge that if there are periods of downtime due to comms loss, then they could have commercial impacts, for example, for us. But that's equally true if we're in the offshore environment and a local computer breaks. There are logistic issues in any operation that we will attempt to mitigate and obviously reduce the risks. but ultimately, yeah, there are potentially impacts from working remotely that we're getting to know as well. And there are even, for example, atmospheric conditions that can reduce communications capabilities that we're learning about, I guess, as we go. And so there's still a process of evolution there. Yeah, same with the commercial modeling.
Yeah. Aren't you afraid that VSAT providers try to benefit from the increase of remote operations and increase their rates?
Well, we've not experienced that yet. I think, ironically, we hope as more people rely on these comm systems, there will be incremental investment from the VSAT suppliers. But I guess it's always a risk, and particularly as we are reliant on those capabilities. Yes, but fortunately, I think it's a fairly competitive market as things stand, so we can shop around for our comm suppliers.
Mike says he hopes that the VSAT people aren't reading this.
Yes, so do I now.
All right, let's see. We also have a smiley face comment here about long-term. Look at companies like Uber and Amazon to see what offshore survey delivery is going to look like in the future. I'm not sure that was really a question or just a comment. Oh, all right. I think that looks like about what I have seen coming in here. I'm going to bring Simon on in case he's caught something here that I have missed. Let's see. I need to be on this computer, of course. There you are. Hey, Simon.
Hi there. No, I think you've covered everything there, Selena. I haven't seen anything else come in
All right.
at this side.
It's been great engagement on the Discord side. Thank you to everybody who has posted questions. You make my day by doing that. We're still at almost 50 people watching the stream, which has been steady over 50 for most of the time that we've been here, which is also really fantastic to see, because that's why we're here. If it weren't for people wanting to join and watch us, then we wouldn't bother. So thank you very much for that. Anything left from you, Dan?
No, thank you very much for the opportunity, Selena and Simon. Thank you.
No problem. Thanks for joining us.
Thanks,
What?
Dan.
What do you say, Simon? Was that a conclusion for the 18th of August, 2020?
Or even the 19th of
Oh,
August
19th.
2020.
It's a definite conclusion of the 18th anyway.
Yeah. No, that was great. Really enjoyed those two presentations there, and thanks very much to the three presenters. So that's fabulous.
Yeah.
Thanks very much for everybody online as well for joining us for this our third event.
Yes, and probably not the last, because it doesn't seem like we're going to be getting back to in-person events anytime soon, unfortunately.
Yes, indeed. I think there should be more of these to come in the future. So from the Hydrographic Society side, keep an eye on the LinkedIn page that we have there, and we'll endeavour to update you in due course.
Yes, same from NOSP. Check out LinkedIn, and here's the there.
There, yeah.
The email addresses, you can contact either Simon or myself through those addresses, and we will make sure you're on our mailing list so that you can keep up to date with all of the upcoming events, whether they're online or in person. Okay, then it's a thanks from me as well on the Norwegian side, and wishing everybody a sunny evening wherever you are, and stay safe and healthy.
Cheers, guys. Thanks very much. Bye-bye.